got models, look at that. Can you get some models on the table? Actually, what's wrong with me? Get some models on the table. We're going to talk about the spinal cord. So moving right along, how was that quiz? This was probably the hardest quiz. As we have learned, the brain is our main neural integration center where many of the sensory pathways end and motor ones start. The cord, the spinal cord, has some rudimentary integration as well, as we will see when we discuss reflexes, but for a large part, it carries ascending and descending nerve fibers in tracts. So ascending are the ones going up. Let's see if this still works. Ascending go up and descending go down. So we have a lot of these tracks. Ascending they color in blue, descending they color in red if you look through the booklet. And they call them tracts, nerve tracts. We're going to learn about those tracts. There's some questions on that. That was probably one of the hardest questions, actually. Oh, so I might have to change that a little bit.
I think it's the way it's laid out in the book, because you have spelling at the start, and so...
Yeah.
Yeah.
Well, I'm actually very happy with the way the book pictures came out on that, in terms of making sense of it and being a lot of detail in a very well organized fashion, but it's still very hard to find it, and so but that's all right. I can push your limits a little bit.
I mean, sorry, it said thickens, so that's why I thought it was. But...
Oh. So we have these, those nerve fibers then travel through 31 spinal nerves to the entire body. In the cervical spine and in the region and the lumbar region, that cord thickens a little bit. And what do we call the thickening in the neck? Cervical enlargement.
Ah, shit. What? Yes.
Did you do that and it got you wrong?
Yeah, I tried all of them.
And cervical enlargement got you wrong?
Yeah.
Did you spell it properly? Well, we had both. We had Karen and I had both. I spelled wrong ones and then she spelled wrong ones, and so we had to talk to each other. But and this is what we're just trying to play with a little bit before class. There's an app on the phone. It's called Piazza, and I want you, if you can or want to or so, download it. And I send you a link to get part of the class, because it's a forum where we can ask questions to the whole class body. And so it's like, if it's like, dude, I tried everything, it's still wrong, and then somebody says like, well, and it's not just one text back and forth. You can also text me. So far we've been texting, some people have been texting back and forth. But I like to, in lab, I'll go around and see some people can sign up, because I like to play with that in the last part of the semester, especially as we get to the last part. Some questions might come up, but then I want to learn if it's a useful tool or not. Some guy from UC Berkeley told me about it. Anyway, in the neck area and in the low back area, we have the cord that you can see here in pink gets a little thicker, and that is because we need to accommodate the nerves that go into the upper extremities and lower extremities as well. So there's a little more nerve cell body action going on, or nerve in general going on, and that's why the cord thickens in those regions. But that wasn't the hardest one yet. Let's go right ahead. Looking at the cord lengthwise, it starts where the medulla oblongata ends, which is around the foramen magnum. Remember that foramen magnum in the head? The big hole in the skull? That's the foramen magnum. It then travels through the spinal canal all the way down to about L1 or 2. We talked about that on Monday. Then we talked about doing an epidural. So 1 or 2 are closes into a tip. It doesn't go all the way down to the coccyx, which is the tailbone, because the spine grows more than the cord as we develop. So at some point, the bone, which is here cut off, it's on the side, the bones down here were the same length as the cord, but then in development, the musculoskeletal system grows faster and more than the nervous system, and so it pulls the cord up as we develop. And at some point, where the cord ends, we have a little tip that gets created, and I think that's the question. What's the tip called? Conus medullaris, or medullaris. That was the one I spelled wrong. I only have one L. It's hard. So that's the conus medullaris. Then afterward, these nerves that come out of the cord up here, they also still don't have to travel further down, some of them, because they exit to the body below the cord. And so down here, you've got a whole bunch of nerves that travel down, and we call that, what do we call that? No, that's the conus is the spinal tip. That would be called that the cauda equina. The cauda equina. Let me show you the picture. Oh, and it's right here. Numero 3.
I have a question.
Mm-hmm.
So if you have a bulging disc,
Mm-hmm.
then it's really going to mess up a bunch of your nerves, right? Like if you have a
Mm-hmm.
bulging disc in your spine.
It can mess you up. So but it doesn't have to. I mean, no, I shouldn't. Because what are you going to do about it? Do you have one?
Yeah. That's what I'm asking.
Yeah, I never had MRI because I don't want them to do anything bad on me. So I can read them, but I don't want to
You
get
say
it.
it like it's pushing on a nerve that's going down my arm, so I have like arm pain sometimes, but it's gotten better through like working out and stuff for some reason. I don't know.
And do you remember the injury?
It's just repetitive motion.
We should talk offline. It's one of those questions. Because I played tennis, so I know this numb thing a little bit too. So what I was pointing to on the model is here in the picture, the tip, this is the spinal cord, and the tip that comes down here, we call that the conus medullaris. And then the nerve roots that come out and keep traveling down before they connect it to between the bone, the intervertebral foramen or sacral foramina, that's called the cauda equina. Cauda equina. The horse's tail. He's like the horse's tail. That's why they call it that. Yeah, this you know, this is pretty language actually. They're trying at least. So when we follow a spinal nerve back through the intervertebral foramen towards the spinal cord, we find it splits right after entering. One arm or nerve root reaches around the cord, entering in the front, and the other ventral, and the other swelling up a little before entering into the back or the posterior side. Spinal nerves are made of both sensory and motor nerves, fibers. Nerve roots carry only fibers that are either traveling into the central nervous system or exit it. That's a tough question. Do the ventral nerve roots carry sensory or motor fibers? Motor fibers.
When I answered the whole question, it got me wrong.
You enter motor and it got you wrong?
Did you put fibers? Because you know if you don't put the
I
whole
tried
one, it's
fibers.
wrong. That happened to two of
Fibers
mine.
without S. I tried everything. They got me wrong.
I will look it back up, but I think that's one where I have like, motor fibers, capital motor, capital fibers, capital motor, small fibers,
But both didn't work.
all those, and fibers even spelled in English.
Right. 'Cause
Even the RE versus the ER, I changed that too. But anybody else has an issue with that question in terms of putting the right stuff in, but it came out wrong? Okay. Well, we'll keep, if it's a problem, at the end, we'll figure all that stuff out. It's not like you got it wrong. So yeah, I mean, just know, if you feel like you're getting it right and you tried a gazillion, you can text me or let's go to the piazza and throw the question to the class. Because I don't want you to be frustrated because you feel like you have it wrong, but you think it's right. Somewhere there is a problem in the system. Sometimes I'm not quite having it right yet. It's the first time for me. But anyway, let's talk about that on the picture, the motor. That was a pretty picture too, huh? This is actually a very good picture for including when I'm clinically working on people. I mean, it's hard for me to memorize all these things, and so because when you have somebody that has some weird stuff, numbness, cribbly sort of feeling in an extremity, you can sort of figure out as you get to the color if you have a really good chart, or it actually one that's more detailed, even it writes it in there, but you can make up which vertebra is going to be a problem. So if you go to the neurologist and they put the pinwheel or something and say, feel that, feel that, feel that, they're testing these different nerve roots, and they can sort of deduce maybe there's something kind of a little like herniated in that area or something like that. And so that's kind of neat to see that. Then we get to this picture, and this picture is the vertebra that you're using on your desk. This neck area here, this vertebra that is on the outside. You see it's a neck because it's got that bifurcated back spinous process. Remember from studying those? And then inside we have that spinal cord. So that thing is the spinal cord that goes up and down the column, inside the column. And here on the spinal cord, actually, let me turn it around, because this is the back. So where the tip goes, that's posterior. In here, that's anterior. That's where you go have a disc. If you have a disc in the neck that gets bulgy, which the disc is in here, it squeezes out to the back. That's the problem. That's when you get some numbness. And I mean, the numbness is actually not really that problematic. What's really problematic is when you drop the cup of coffee and you can't hold it. That's what's problematic. Because in my opinion, the numbness, and research will show you, the numbness you can work very, very different many ways, and has many different causes too. It's not just this that can be a cause for this numbness. And there's, especially in the neck, you're not going to do surgery. You're going to strengthen neck muscles. That's really the key ingredient here, because surgery in the neck area is extremely delicate. Down in the low back, it's much more successful if the diagnosis is good, I think. So anyway, when you look at this, so this is the front, this is the back. And then when we look inside where the spinal cord is, we see these little pieces that come out here in the front and some in the back. You see that on yours? Those are those roots. Those are anterior and posterior roots. And I made a red for anterior, and red is motor. Motor is the stuff going out of the brain to the body. On the brain, the precentral gyrus is red, that's why. Or reddish on your brain. And so the question was, what's the ones in the front? Those are motor. So the anterior roots only carry motor fibers. The posterior roots in the back only carry sensory fibers.
Wait a minute, can you say that again, please?
The posterior roots in the back of the cord only carry sensory fibers. So, if you look at a nerve impulse, you have the nerves that come in here from the outside in. They travel and take the route on the freeway that goes one way, and that goes upward, and that goes through the back. And then you go up to the spinal cord upwards. So you go up to the spinal, to the brain, upward. And then the fibers that come from the brain down, the motor fibers, they exit the spinal cord through the back. I mean through the front, sorry. Okay? We want to have this spinal cord very well organized. These are all cables in here, like the telephone cables. And so where the message needs to travel, there needs to be a cable. So in here, this is very, very well organized. That is why, on this level, everything that goes on here pretty much has to do with information going out from the brain and the central nervous system to the body. Everything in this area pretty much has to do with information going into the brain and the central nervous system from the body. So that's why at the nerve root level, they are either motor or sensory fibers. And then as they come together, before they exit the bony encasing here, they come together and join together, and at that level they're called a spinal nerve. So at the level right here where they are together, that's called the spinal nerve. And the spinal nerve exits the spine. And then right after it exits the spine, it goes to the back. Some part comes off, goes to the back area, and some goes to the front area. That's why you have to split back here again already. Another landmark that's very important on here, that's probably the next question, but we're going to do this right first here, is see this swelling here? On this model, it's right here. You see the swelling here? That swelling are all the sensory neural cell bodies that carry the information from the body in at that level of the spinal cord.
So
the bulge is cell bodies clustered together, so they're like all protected and they don't get squished. Because the nerves come from the outside, in from the skin or somewhere, into the spinal cord, and those extensions are dendrites, they're not cell bodies. You don't have too many cell bodies of the nerves in the extremities or in the periphery. So
then this spinal nerve is right before that bulge?
yeah, so the spinal nerve is here, and then when it splits into the root, then you get the bulge. And that bulge, you know, is a sensory cell body, so therefore you know where the bulge is, you have sensory fibers going in.
Okay, so on the model, the spinal nerve is where?
The spinal nerve is here,
Okay.
where it's
More on the
covered.
brain. Okay.
No, you know, I mean, it's a little bit tough. I mean, if I label it spinal nerve, I label it right here.
Okay,
If I go here, I'm gonna go where you can see where it goes in.
yeah.
But I will very likely label the bulge itself as the dorsal root ganglion.
Okay, so the
Can you point to the spinal nerve one more time?
Yeah, the spinal nerve is where it's right next to it, where it's all wrapped up.
below the yellow?
After the yellow,
Is
yeah.
that- that's
Yeah,
spinal
after
nerve
the
right
yellow,
there?
yeah.
Oh, okay.
And if these are the detailed questions and the test is, and I'm not clear, you call me over and make me sure I tell you which one I mean. You know, I don't want you to be worried about guessing and then you feel like you get it wrong. That's anxiety. We don't need that. Mm-mm.
It's already there.
I'm in the world to try to decrease my own anxiety. That's why on Monday the exercise was for me. You got that, right? That wasn't for you, it was for me. Anyway. Because I have hope that if I teach it, I might learn it. So, but it's interesting though, when you then know, when you see a bulge, you can orient yourself. You know it's the sensory pathways, then you know that's the dorsal side, the back side of the roots, you know. The roots are connected to the dorsal root ganglion. All right. And again, that brings up the discussion. A ganglion is a cluster of cell bodies in the peripheral nervous system, outside of the central nervous system. The term nuclei, like red nucleus and that kind of stuff, is when it's in the brain. So that's the difference in the terminology. And that's why when we talked about the basal ganglia, remember the term the basal ganglia? It's kind of the wrong naming because it should be called the basal nuclei. And in some modern text, you will find it labeled as the basal nuclei. So then you know that's the same thing. So be aware and don't question yourself too heavily. All right, let's go to the next piece here. The nerve roots on the posterior dorsal. The nerve roots on the posterior dorsal side swell a little bit. What are the swelling called? We just talked about that. What are they called?
The dorsal root ganglion.
The dorsal root ganglion. Good. Looking at a cross section of the spinal cord, we find a reverse order of white and gray matter that we found in the brain.
Yeah.
So here, the white matter is on the outside, the gray matter is on the inside. And remember, the white is myelination of axons. It's the insulation of the nerve fiber, right? So that's why it's white, because it's fatty. It's fatty tissue. In the spinal cord, the white matter, which are myelinated nerve fibers, travel up and down the cord. They are more on the outside versus the neural cell bodies that provide rudimentary integration. So that's like a reflex. You know, when you have a reflex is when the tendon stretches and there's a danger that you rip the muscle because it's such a fast stretch. The body doesn't know that. The information goes into the level of the spinal cord where we have the sensory information goes in through that DRG. And then right at that nerve, at that level, you're going to have a reaction that kicks the leg out. That doesn't go to the brain, that reaction. The reaction happens right there. That's a rudimentary reaction of a muscle stretch. We will realize in the brain that our leg went out and go like, whoa, how did that happen? But you kind of see it and feel it a little bit delayed. I did have a guy, I told you that, right? I did have a guy come in and he was about 50-ish and he came and I did the reflex on him and he's like, you really do that? I thought that was only in the movies. It was so funny. It's like, yeah, you gotta do it. It does tell us something. Anyway, the gray matter shape sort of resembles a butterfly. It has different swellings or horns arising from the front, side, and the back, carrying neural cell bodies belonging either to the motor system, the sensory system, or or the autonomic part of the nervous system. In which horn do we find the somatic motor nuclei? Whoa, that's a challenging question. The way I ask it. In which one? Yes. So you associate motor with motor. There we go. So you associate motor with anterior you associate with ventral, it's just an old term. That was in the chapter 1, anterior ventral. This is the place we still use it. So that's where it's read. So the somatic, everything that goes to the motor means muscle. Whenever you see that, you see muscle, the doing something. That is in the front right here. The horn that has to do with integrating sensory stuff, where would you find that? Here or here? The top or on the side? The top, right where it comes in. The one on the side is the autonomic efferent nuclei. That's like your fight or flight response stuff, or your rest and digest response stuff. Okay? Well, what I want to make sure you get is that the front is the motor nuclei, and then the motor root before we get to the spinal nerve, where we exit the cord. And the back is the sensory roots coming in, and then we have the sensory nuclei right there as well that integrate the information from the sensory perspective.
Can you explain the rest and digest?
We're gonna get to that, I think, at the end of this, right? I think so. I hope so. Yeah, down here.
Oh, yeah, with the stomach.
So let's do that at that point, huh?
Okay.
We'll make sure we have a little time for it, though. So you got it so far? Any questions that come up? Let's review. Spinal cord, mostly nerves, axons going from the brain to the body. Some of those tracks, some of those nerve things, the axons, go up from the body into the brain. We call those the afferent or sensory nerves or tracts. They're blue. And then others come from the brain and the spinal cord go out. And those are the nerves, the motor or the efferent or descending tracts. We do have cell bodies at the spinal cord level. Oh, and then the motor information goes out in the front of the cord, and the sensory information comes in to the back of the cord. The motor stuff from the brain out goes out in the front of the cord, and the sensory from the stuff that comes from the body into the central nervous system of the brain comes into the back of the cord. Then we have cell bodies, because when we start looking at the tracts, the pathways, we will have a change from the sensory nerves coming in. They're gonna bring the information into this area here, and you see this split here? That means right there, there's gonna be the next neuron. So when you look at information going from the body into the brain and the spinal cord, you have a neuron here that brings it to this level, and then it hands off the baton, so to speak, to the next neuron, and the next neuron sends the information up to the spinal cord.
So you call that, what did you call that there?
Well, it's got to be a synapse.
Synapse.
Oh, we talked about synapses already. Yeah, it's a synapse. This is a synapse. One nerve to the next nerve. This is why we then call it secondary or second order neuron, third, that kind of stuff. And then when you look at the motor output, you're going to have the info coming down to this level, and then here is a synapse, and it sends it out on the spinal cord from there. And so you're going to have a bunch of cell bodies inside the spinal cord. And then sometimes, like when we do a reflex, there is a neuron that connects the two right away, and you don't even go up to the brain. You just go straight through the spinal cord. But these cell bodies need to be in somewhere, and so on the spinal cord levels, they are in these gray horns, in these anterior, lateral, and posterior horns that we call. And when you look at the whole structure, you can sort of make up that looks a little bit like a butterfly. When we used to have butterflies. Never mind. Make sense somewhat? Yeah, good. If you get to this level, you're pretty good, I tell you, because a lot of the rest is just naming stuff. Looking at a cross section, we talked about that. Oh, I did have one of those in there. Oh, this was.
It should all be that.
The tract. Yeah, this was a nasty one. Hold on. The tract in the cord are well organized, mostly names according to their origin and destination. Where they come from and where do they go? Yeah, no, this was a very specific reason for this question. I thought I should do a fill in the blank, but thank God I didn't do that.
You should take those out, you know?
What? The fill in the blank?
Don't y'all agree?
You don't like that? You don't like that?
No.
Don't they make you think deep?
Causes us consternation.
Well, if you misspell a word, if you don't put two words, if you don't put three and they really meant two, it's a pain in the butt.
Well, I refuse to misspell the answers. That one I refuse, even if I have to correct my misspelling. Well, but you did it, right?
Yeah, but woo, I had to walk away and come back to it.
Make you mad? It made you mad? If it make you mad, we gotta talk. But otherwise, So anyway, most said this is, but I swear this is definitely one of the hardest chapters.
Yeah.
This organization, because we're all of a sudden we're switching from the brain where this means this and this means that, and it's kind of cute. Now it's friggin' electricity. It's all that's like weird having to visualize, organize this kind of shit. So we'll just and then afterwards we get into special senses. That's kind of cute. It's like out of the eye work. So it's kind of nice. Yeah, we're gonna dissect an eyeball, I think. Okay, most of the sensory fibers carrying information that's destined for our consciousness make a stop at the thalamus before they reach the consciousness. Ooh. Okay, so the thalamus is important here, huh?
Yeah, it is.
Which tract carries pain fibers into the brain? Good. So after all this nightmare, you figured out how it works, right? Good. Ha. Spinal, from the spine to the thalamus. That's a big one. And the other one that's huge for us is the corticospinal tracts, because those are actually the pyramidal tracts. From the brain in the front. Remember those tracts from the brain in the front? That we just had that quiz about? Stephanie's trying to be hard ass on me. But that's those tracts. So from the cortex to the spine. And then at the level of the spinal cord, we flip over and go into the extremity. Let's look at that at the picture. Because this is some, I mean, I tell you, if you know this level, you pass chiropractic school. So if it's a lot, I understand. But if I don't give you the fundamental of how it's like worded, the concept, it's just a bunch of freaking words. And then it's really complicated. And so at least that's why I want to go a little deeper than I may have to in an introduction class. But that's why we have a really good test review. And don't worry, I'm not going to have a quiz question, you know, the one that looks like a little bit there. Which is that name for it? That's not going to be on the test. No, the test questions are fairly minimal for this stuff.
Can I ask you something?
Mm-hmm.
We're labeling this, but are there going to be questions on the test? Like the true, false?
No. The
just
questions on the test is whatever, but I don't think it's all, I think that's all anatomy.
Yeah, it's all anatomy.
Yeah. No, this is partly because it's so complex.
Yeah, okay.
Yeah. No, and the anatomy, I do have extra add-ons on the anatomy list. Uh-huh.
That's fine. I'd rather have that than.
So where were we? So let's go through we did the corticospinal tract, right? So we have, where was that? So the corticospinal, now the spinal thalamic tract. It's got to be something that's blue, right? Well here, spinal thalamic tract. So there you go. So you have some that come from the cervical, thoracic, and from the lumbar area. And so you got them all. You got a whole bunch listed here. I mean, just put that away, and when it comes back in the neurology class, you might have a picture that helps. I thought it was pretty good. This is also a pretty good one, I thought, because what it shows is the amount of neurons that we have, and I think that was a concept discussion. So let's just do that now since we're at it. When you look at the blue is sensory, so the blue is information from an ending, like the water temperature coming in to the spinal cord in the back where the swelling is. That's the nerve root, right? The posterior, dorsal. And then there we have a synapse. Well, the synapse they indicate up here, but it's at the spinal cord level, where the spinal cord comes in. That's where the synapse is. And then so that's a primary neuron. That's the first order neuron. And then we have from that area here, from the spinal cord, this is at the spinal cord level. We're gonna have one that goes up to the thalamus. And then we got another synapse, because the thalamus is gonna sort out all the information. So they're like, well, that's a hearing. That's a feeling for this, and that's a this kind of thing. And it puts it wherever it needs to go to different parts of the brain. And so that's the second order neuron. And then the last one brings into this one goes to the postcentral gyrus at the cerebral cortex, and that's a third order neuron. When we look at the motor output, we look at red. We start at the precentral gyrus, and we got one that's going from up here, that's not red, that's brown, that goes all the way down to the spinal cord level, at the level of where the nerve comes out of the spinal cord. And then there we have a synapse, and from there the nerve goes to the muscle, that needs to retract or whatever it needs to do if the water is too hot. Contractors. So here we only have two orders. We have a first order, we have a second order. Although what we're going to call that here, we call it, the top one we call upper motor neuron, and the one below we call that the lower motor neuron. So we don't call it first and second. Well, maybe we do that too. But upper and lower is more helpful for us, because we're going to have a pathology that comes on that. Does that make sense? Yeah? Yeah? Good. So we have two chains going out and 3 neuron chains coming in because of the thalamus. Good, let's see where we're next. Well, that was it. The rest is easy, right? Many of the tracks that describe, are connecting primary motor cortices, the forebrain, the skeletal muscle. The majority of them cross over to the left to the right, vice versa, at the medulla oblongata before. That's the accusation of the pyramids. Before then going down the spinal cord level of the muscle innervation, where they synapse and second order neuron. Along the way, the conscious wanting to move a muscle is influenced by different structures. Can you name the 3 listed in the slide? Choose all that apply. Yup. Good. Brainstem, ganglia, and cerebellum. So this is the discussion of you're going to walk over to the light switch to turn on the light, and the brain starts saying, oh, I got to contract these quads and other things, and then you realize, oh, I've walked before, I can walk. So it's a rhythmic motion. That happens in the basal ganglia. Then you don't have to think about the walking no more. It just goes automatic. But then the problem is, and then down here we have stretch receptors and stuff like that. And then the problem is you fall into a pothole that you didn't see, and you get out of balance, and the cerebellum needs to make sure you don't fall down. And so the cerebellum helps the balancing. So that's sort of my story, the way I have it in my head. I think it's pretty easy and doable. Well, neurology is hard. You know, you gotta make some sense out of it where you can. You know, look, there's a lot of information on here. See that? You like my arrows that I made? I know. I try to explain it as well as I can. See, that's pretty clear. At least I hope. Where was I there?
Go back.
Go back? Yeah.
Oh, no, I think you're trying to find where
You know this one?
the last question.
These are these are all just names of tracks. Where I also wanted to go though real quick is, because this is a plexus, so before we get to the plexi, I wanted to talk back a little more about that upper neuron and motor neuron lesion. So in the motor system, we have the upper motor neuron goes from the presenile gyrus to the level of the cord, and there it synapses and goes to the lower motor. That goes to the muscle. Now, when you have an injury, you can have damage to if you have damage to the neurons, it could either be the upper motor neuron damage or lower motor neuron damage or lesion. And if you have a lower motor neuron lesion, meaning you got that disc slamming right onto the nerve and impeding that nerve from, getting the information out, but it's the lower motor neuron, you're going to be having a limp, whatever muscle that it fires onto. It's not going to function. That muscle is going to be limp. They call that flaccid paralysis. It atrophies. But on the other hand, if you have an injury in the upper motor neuron, not the lower motor neuron, what's interesting is when you actually look at really muscle function and nerve firing patterns, you get into patterns. And the lower motor neurons fire constantly, and a lot of what happens with the upper motor neurons, it's inhibiting the firing to balance it all out. So it is more complicated than we make it seem at the end of the day. And so when you have an upper motor neuron that gets leased, so maybe a stroke, something like that in the brain, you're going to get a spastic paralysis because the muscle and the lower motor neuron, they function unimpeded like crazy. So that's when you see the people like that. Because the flexors are stronger than the extensors. But they both want to contract. So if you see somebody like that and you just, you know, whatever goes through your mind, I don't know, maybe it's like whatever it is, you do it and feel for it and go like, holy shit, that hurts like crazy. Those
So
people that
when
been doing
somebody
that.
gets So when somebody gets like in a car accident or has some form of accident and they become, is it a paraplegic? Is
It's
it-
flaccid.
It's under flaccid? Okay.
You see the spastic when they sit like that. You see that's more like stuff, clear stuff. That's more brain stuff. So I thought I mean, it's not interesting. I mean, no, it's interesting. It's painful and it's problematic, but it's interesting because you can sort of see fairly directly on the outside what a pathology on the inside is. It's good when, you know, when we study pathology, one of the things we want to see is look for signs on the outside that can identify stuff. You know, that's why we look at eyes, we look at nails, we look at skin stuff. Where we can identify things is helpful. Okay, then after that, we're going to go to the next topic, and that's reflexes. It is very important to the body that nerve impulses, skeletal muscle, which move us around the world, are well fed. Looking at the pathways from the brain to the skeletal muscle, the nerve roots is most vulnerable to damage. So where the nerve comes right out of the cord is most vulnerable. That's why a herniated disc can be such a pain in the butt. It's so vulnerable right there. Disc herniation. Our body is smart figures therefore to feed a muscle from multiple different spinal cord levels. This way it avoids a complete muscle shutdown if one of them is impeded. Can you name the plexus the nerve impulses feeding the biceps brachial travel through? The brachial. Everything up in the upper arms, brachial plexus. Down here, lumbosacral plexus. Sciatic nerve. It's a big one. Lumbosacral plexus. Yeah, I differentiated them, but basically we go with lumbosacral plexus and brachial plexus. Those are the two big ones. And the brachial plexus is very complicated. I mean, if we go in other classes, you have to study that thing and like go, where is it? Hey, where's my slide of plexi? Is it in the book?
Yeah, page 41. Page 41.
Oh, here we go. So you see how the cervical is small up here. But see here, you see all these things, all these track changes, they all have names. And so depending on further on, you're gonna, you learn all these different names. Because it is an important rearrangement that makes sure that the muscles get fed. And so when you actually feel on your above the clavicle and you feel that, and it's kind of hard in that tissue there, in that muscle, that's the scaling muscles. And if you get a nervy, ropey thing, that's one of those things you rope over. And so when you massage somebody, they're going to be careful you don't do too much nerve rubbing. Try to stay on the muscle. But it's okay to be deep. You have to be deep sometimes. Okay, so that's that brachial plexus. That's what I wanted to talk about. That. Oh, look at that. That's the end of that. That was a short quiz. I'm sure. I know, right? So I'm sure I missed a whole bunch of stuff. We talk cranial nerves. So let's go to the concepts, because that's in the concepts, right?
Yes.
This is very small here, huh? Yeah, I gotta keep it. The outer layer of the spinal cord is white matter and nerve tracts. Inside of them are nerve fibers traveling up and down the cords. Those fibers make up pathways of multiple neurons that connect the brain to their respective peripheral target organs or receptors. Good. How many neurons are in the sensory? How many in the motor?
3.
Good. No? Motor? Motor 2 or 3?
2.
Good. Then I heard you wrong. Good. And sensory 3. I know, I'm sorry. Something very cool, well, it makes you stronger. Something very cool that happens at the spinal cord level or hardwired feedback loop. This is where receptor, such as pain, temperature, stretch receptors, pick up a stimulus that can be reacted to the same way every time. For example, if temperature sensor in your finger burns up, you want to pull it away from the heat source every single time. We don't really need to think much about that, it just happens. Can you explain how the patellar reflex works?
Well, there's one.
That one.
One synapse, so it's, makes it fast,
Uh-huh.
you know, like when you hit it.
Uh-huh. And what are the steps? What is the negative feedback loop steps? It's the same thing again, right? Yeah, go for it. Yeah. No. Receptor, let's go for it.
What did I put?
Here we go. Didn't you like that picture?
No,
It's a great picture. So we have, yes, keep it up.
Contraction of this muscle.
Yeah, so you have, when you look at that, maybe I should ask the question, what's the reflex arc pieces? I think maybe I got a bit better at that. But what I was looking for is the fact that you have a receptor. Here we go, this is easy. A receptor that's, except the colors are mixed up. A receptor that picks up a stretch, for example, or any sensory change that we want to pick up. In the patellar reflex, it's the stretch of the patellar tendon. And it feeds into the spinal cord and directly goes from the sensory side to the motor side. And with an interneuron, and then has an effector going to the muscle that will contract. The concept is basically always the same in these things. So information is picked up, sensory gets pushed, sensory information travels into the central nervous system, this cord or the brain, and then in there's some integration happening, and then a motor output gets sent out of the spinal cord or the brain or spinal cord to an effector to have a reaction. Info in and out. We need to have information to figure out what we need to do with this world, and then we have a reaction to the world.